In today's class, we're going to discuss about the RSA algorithm already discussed. It is revisiting the particular RSA algorithm. So what is the RSA algorithm? Examples are available. As you know that RSA algorithm is a most popular and proven asymmetric algorithm. So it is a cryptography algorithm. Before we discussing about how quick overview of about prime numbers, and it is a so the large prime numbers it is a cannot able to detect. So it is a so they are taken into consideration here. So that is A and B are the two large prime numbers. So computations of these into so factors are finding it is a very difficult. That is a mathematical. They are taken. It is a look like a very simple algorithm. So it is again factors are finding to the bit so large numbers. It is quite difficult. That is that they are taken so and also find x and find y. They are calculated from this. Once it is a calculation of computation of these two large prime numbers A and B, so multiply with each other and the factorization will be done, and they select the encryption key such that x and so that is a finding of x, and also before that it is a do the computation of y of n. So it is a minus 1, it is again multiplied with the b minus 1 are the relatively prime numbers they have select. So and find y and calculate the so decryption key y with the equation of x into y mod a minus 1 and b minus 1 is equal to 1. At this point and the a and b are discarded. So to pair of keys like public key and private key, so pair they are taken from the x comma 1, that is so whatever selected x and n computation with the two large prime numbers they have taken as a private public key and private key y comma n they have taken. And as you know that it is both sender and receiver must know the value of n. So that sender so knows the value of x. That is a user A assume that it is a sender, so only know the value of x, and user B is a receiver, so only know the value of y, and ciphertext can be calculated using this equation. C is the ciphertext, m is the plaintext to the power of x and mod n. So modulation that to be taken place, and it is a decryption given ciphertext C, the plaintext m is extracted by m is equal to c to the power of y mod n. This is the decryption algorithm. So that is so methods they follow here. So and so examples for this and for an encryption algorithm of 4-bit message they have taken here. So here, so that is 4-bit messages they are taken as 100. So 100, that is nothing but m is equal to so 9 in integer number. So that is a binary of 100. We choose A and B. A is equal to 3 and B is equal to test for the two small but as actually it is a large prime number they are taken for computation. For a testing purpose they are taken for A is equal to 3 and B is equal to 11. Find the public and private key for this security action and show the ciphertext. So that is exactly examples. So here select two prime numbers, that is A is equal to 3 is given, B is equal to 11 is also given. So it is a compute this, n is equal to A and B is equal to 33. So will be get back, and A is 3, B is 11, 11 3 is so this is 33, which is relatively prime to and compute so pi of n is equal to A minus 1. A minus 1 is A is 3, it is 2, and B minus 1 is 11, it is 10, 10 into 10 to is 20. So we select x is equal to 3. So it is exactly find the prime factors, and it is a prime factors through which we are getting x is equal to 3, and then it is you can add to the so for following equation before finding the y, x into y mod a minus 1 and b minus 1. So that is a 3y. So that is x value. So that is a 3. So it is multiplied with the y and mod with that 20, and it is a 1 will be get back. So 7 into 3. So it is a guessing number is 7. That is a y. So if it is 7 into 3, it is 21. That is the reason. So 10 into 2. So that is a 20 plus 1. It is a 21. It is a prime numbers, relatively prime numbers we have taken here. Consequentially, public key is a 3. So 3 is x value. So and 33 is the computed value of n is equal to a into b. So that is 33 will get back here, and 7 is the so that is a y value, and 33 is the so computed value of a and b. It is respectively they are taken as a private key and public key respectively. So here if we encrypt the messages using this equation, C is a ciphertext. So how do you get the ciphertext? M to the power of m is the plain text, and x is the so that is a so power and x mod n. So you can apply this like equation. This is so n m is given to you. So 100, it is nothing but a 9 to the power of 3 and mod with the 33, and we are getting the 3 is the ciphertext here. So this decryption process reverses this action. You do that. So m is a, so we can so m is a, so that is a, so m is the, so we can get back the plain text. So you can take the ciphertext to the power of y and mod. Ciphertext is nothing but it is a 3. So 3 is the ciphertext and the power n is, so y value is a 7. So you can take this y value and mod with again the 33, and it is a, so this 33 value should know by so sender and receiver. That is the reason 33 value. So it is taken, and it is this so will be get back n9. So that is the plain text is getting back. So the message is 100, that is a binary message, or m is equal to 9 will be get back. So this is how, so it is look like a simple algorithm, but it is a, so mathematical computations of large prime numbers. If you have done factoring the particular prime number by the hackers are not so easy, and also so guessing the private and public key is also not easy. That is the reason it is a strong asymmetric public key cryptography algorithm. So one more examples are also available. So in the similar line, it is exactly, it is works. RSA encryption of 4-bit messages, you can take R, it is directly, you take M is equal to, value is given to you. M is so 88. So we choose 17 and 11, B value, 2 prime numbers. If it is prime numbers, it is increased as some so 2-digit number. They are taken 17 and 11. Find the public and private key for the security action and show the ciphertext. You see that select 2 prime numbers. So that is 17 given, B 11 is given, and computations of n is equal to multiply with the B and 187 it is getting, and the factorization this 187. So x value we can get it is as a 7, and before factoring, that is computations you can do it, and a minus 1, that is a 160, it is a value, this 160. So this value, so it is a computation value, and then it is formed. So this equation should apply. So x value, x is equal to 7, they are taken 7 into y mod 160, it is 1, it is at so 10 so into, so 160 into 10, it is a nothing but it is a, so one value, so that is 7 into 23, so it is a 160. So that is exactly value, that is the factoring value 161, that is exactly, consequently the public key is equal to 7 into, so that is 187, and the 23 into 187 respectively. To encrypt the message m is given to you. So it is a ciphertext you are calculating. C is equal to message m, so whatever the given value, so to the power of x. So given value is 88 to the power of 7 mod with the mod operation we can perform with the 187. You can get the ciphertext as a answer is 11, and decryption process and reverse of this action, and is m is a plain text. We can want to get back this again, it is a given plain text is 88. So do the decryption process. This is equal to y to the power of so whatever the value you are getting. So that is a c to the power of y. It is not y to the power of y. It is c to the power of y mod n. So that is 11 to the power of 11 is the number of ciphertext. 11 to the power of 23. So mod 187. It is again we are getting back the given plain text. M is equal to 88 plain text is given. So that should be get back. So in this class, so we have discussed about again RSA algorithm. We can revisit it. It is a very so popular asymmetric algorithm. So I think it is having a asymmetric key like private and public key pair. It is available. It is using prime numbers, large prime number. They are taken as 2 prime numbers. So I think you all learned, and with examples, some 2 examples also we have discussed in so this class. That's all about this RSA algorithm.